recursive way. So this is the very simple problem, that is to compute factorial of a number. Now, what are the instructions? Here first you have to check the value of n. So if the value of n is either 0 or 1, it returns 1. That means here it takes a constant time, only one comparison is there, or you can say here as per the program, two comparisons are there. But if the value of n is not 0 or 1, then it will call itself. That means fact n call fact n minus 1. Similarly, factorial n minus 1 call factorial n minus 2. Factorial n minus 2 call factorial n minus 3. It means we are just converging to the base condition. So we have a base condition. Just a minute, pen tool I have to pick pen tool. Okay. Again, admit. How many times I have to admit? Okay. Sorry. So here, then after factorial n will call factorial n minus 1, then factorial n minus 1 will call factorial n minus 2, then n minus 3, n minus 4, dot, n minus 1. That is what? That is factorial 1. So factorial 1 means what? It means we already reached to the base condition or terminating condition. Now factorial n will complete. When factorial n will complete? If and only factorial n minus 1 will complete. Similarly, factorial n minus 1 will complete if and only factorial n minus 2 will complete. Similarly, factorial n minus 2 will complete if and only factorial n minus 3 will complete. Dot. Similarly, we can say factorial 2 will complete if and only if factorial 1 will complete. So factorial 1 means what? It's a base condition. So the corresponding recurrent relation, once again I am saying T of n. So for T of n? T of n means time taken to execute the program of size n. Okay, so here the program or the problem is what? To determine the factorial of a number n. So T of n means time taken to execute a program of size n. Similarly, T of n minus 1 means what? Time taken to execute the program of size n minus 1. So if n is equals to either 0 or 1, we can say T of n is a constant time. Now the second one, which is very, very important. Here the recursive features comes. T of n is equals to T of n minus 1. Already I have said fact n, to complete fact n, you have to complete factorial n minus 1. To complete factorial n, you have to complete factorial n minus 1. So that's why, so the time of fact n is what? Let's assume that this is Tn. So Tn will be what? Tn will be T of n minus 1. What is T of n minus 1? Time taken to execute the problem of size n minus 1 plus some constant. What are the
Sir, your
constants?
voice is weak.
Hello? Hello?
Sir, your voice is leaking.
Yes,
My
sir, your voice
voice,
is not clear.
Yes, sir.
is it clear? My voice is clear. My voice is audible.
Yes, sir.
Okay. Then mute again. I will start. Okay. So T of n is equals to T of n minus 1 plus some constant of how many times? How many times? Saurabh Karak, this is my final warning. Always enter the class at least 5 minutes before. Otherwise, I will not allow you. This is my final warning to everybody. So T of n minus 1 plus B. So plus B means what? Some constant. What kind of constant? Because some multiplication is there, one multiplication, one subtraction, because initially we have n, now it's n minus 1, one comparison. So as a whole, this is B. So the recurrent relation is T of n is equals to some constant, when n is equals to either 0 or 1, or T of n is equals to T of n minus 1 plus B, when the value of n greater than 1. Now, I have to derive the time complexity. So T of n is equals to T of n minus 1 plus B. So this is equation number 1. Now, here, if T of n is T of n minus 1 plus B, then we can write T of n minus 1 is equals to T of n minus 2 plus B, because to completion of fact of n minus 1, we have to complete fact of n minus 2. So T of n minus 2 is what? Time taken to execute the problem of size n minus 2. That means if T of n is T of n minus 1 plus B, then we can write T of n minus 1 is equals to T of n minus 2 plus B. Now put the value here in this equation 1. Put the value here in this equation 1. So what you will get? T of n, replace T of n minus 1 by T of n minus 2 plus B. So you will have T of n minus 2 plus B, and this B is also placed here. So T of n is equals to, we can say T of n minus 2 plus 2B. Similarly, T of n minus fact of n minus 2 will complete if and only if fact of n minus 3 will complete. So that's why just represent T of n minus 2 by T of n minus 3. So that's why we can write T of n is equals to T of n minus 3 plus 3b, n minus 3 plus 3b. Okay, similarly, T of n is equals to T of n minus 4 plus 4b. Now, in this way, if I write, then last you will get T of n is equals to T of n minus 1 plus n minus 1b. This part is clear. Is this clear now, anybody? Is this clear now, anybody?
Yes, sir.
Yes, sir.
Okay. So if T of n is equals to T of n minus 1 plus some n minus 1 into B, then from there we can write this is what? This is T of n, T of 1. Now what is T of 1? It's a constant. What is constant here? The constant is A. That means we will get T of n is equals to A plus n minus 1 into B. A plus n minus 1 into B. So it's a linear equation. It's a linear equation. A is constant, here B is also constant, and asymptotically we can say n and n minus 1 is same. N and n minus 1 is same. Last day I have said several times. N minus 1, n minus 2, n by 2, these are all asymptotically same. So that's why we can say the time complexity of factorial is order of n. So we have implemented factorial in recursive manner. We have implemented the factorial in iterative way also. And we have seen the time complexity of factorial using iterative way as well as recursive way, that is same, that is order of n, or you can say big O of n, big O of n. Now any question from anybody, please ask. Srinjoy, why are you late? Srinjoy, why are you late? From the next day, I will not allow anyone. I will not allow anyone. Always try to join at at least 5 minutes before. At least 5 minutes before. And if you have some question regarding the last class, you can join 10 minutes before also, because I will open the link 10 minutes before of my scheduled class. Okay, now is it clear? Very simple thing. T of n is T of n minus 1 plus b. Now we represent T of n minus 1 by T of n minus 2. So just put n is equals to n minus 1. What we will get? T of n is T of n minus 1 plus b. Put n minus 1 here. So it will be T of n minus 2 plus b. Similarly, put n minus 2 there. What we will get? T of n minus 3 plus something. So this is the way I elaborate the equation. Nothing else, nothing else. That means the size of the array or the size of the problem will reduce by 1 for each and every recursive call. Initially, suppose the value of n is 6. That means initially the problem starts from fact 6. So we can get the result of fact 6 if and only if we have the result of fact 5. So now fact 5 is what? Again it will call itself. So to get the value of fact 5, you have to call fact 3. To get the value of fact 3, you have to call fact 2. To get the value of fact 2, you have to call what? Fact 1. And fact 1 is what? It's a base condition or terminating condition. So that's why I have written T of n is equals to T of n minus 1 plus b. Next, replace T of n minus 1 with the help of T of n minus 2. That's why this is T of n is equals to T of n minus 2 plus 2b. After that, replace T of n minus 2 by n minus 3. So what you will get? T of n is equals to T of n minus 3 plus 3b. Then it will be n minus 4 plus 4b. After that, it will be n minus 5 plus 5b. Dot. It will come to T of 1. So T of 1 means what? T of n minus n minus 1. And here it will be n minus 1b. Now T of 1 is constant, that is declared a here. So a plus n minus 1 into b, it means this is order of n. No n square terms are there, no log n terms are there. Now someone says a plus n minus 1 into b, along with some n square terms are there. Let's assume you will get equation like this: a plus n minus 1 into b plus n square. Then what will be the time complexity?
N square.
Exactly, order of n square, because this is the higher term than this. Similarly, if you have log n plus n log n plus n square, if you have, then also as n square is the higher term, the time complexity will be order of n square. Okay. Okay, now I will not join anyone further. Next, I will discuss, which is very important, and each and every time short note has came to the semester, and this time also I will give the short note in the class test. That is short note of abstract data type, which is very important. In abbreviation, we can say ADT. Now, what ADT is? What are the examples of ADT? First, I am giving you the example. The examples of ADT are stack, queue, tree, graph, list, and all. Now, the first question that may come to your mind, in my last class or last class, I have said the examples of data structures are stack, queue, linked list. Now, today I am saying the example of ADT is stack, queue, tree, linked list. What is that? What is the difference between ADT and data structure? What is the difference between ADT and data structure? So when we implement stack, it will be a data structure. When we implement stack, it will be a data structure. When we implement a list, it will be a data structure. When we implement queue, it will be a data structure. But when we represent, sorry, this is stack, okay, this is stack, this is K, not H. But when we represent stack as a mathematical model, Q as a mathematical model, list is a mathematical or theoretical model, on that time we can say this is ADT. So ADT is basically implementation independent. We have to ignore or hidden the implementation part. Is this clear? Now, come here. So an abstract data type is a theoretical or mathematical concept for data types. It's a special kind of data type whose behavior is defined by set of values and set of. This part is very important. Suppose we have a stack. Say the elements are say 5, 6, say 9, say 10, say 12, and so on. Say this is your one stack. This is your top variable that points to the topmost element. Now, what it says, it's a special kind of data type whose behavior is defined by a set of values. What kind of values? These are the values 5, 8, 9, 10, 15, 12, and the set of operations. So already you know what are the operations are performed on stack. The main operations are push operation. Similarly, pop is also another operation. Display is also one operation that can display all the elements from the stack, and pip is also one operation. Pip means it display only the topmost element. Pop is what? Pop removes the topmost element. Pip only displays the topmost element, not remove. So this is the basic difference between pop and pip. So these are the operation, and here these are the data. So it's a special kind of data type whose behavior is defined by a set of values and a set of operation. Now, why the keyword abstract? The keyword abstract because how those operations are working and implemented, that is totally hidden from the user. That is totally hidden from the user. Now, I am telling you, a stack can be implemented using can be implemented using linked list. Clear? So if a stack is implemented using array, it means the operations that is push, pop, display, peep, these are all operations that can be implemented using array, or that can be implemented using linked list also. But how the operations will implement, this is totally hidden from the user. That's why we can say it's a theoretical concept. ADT is a theoretical concept. So whenever we represent stack as a mathematical model or theoretical model, we can say it's a ADT. Whenever we implement stack, then it will be a data structure. Okay, now let's give you another example. Suppose you have a problem P. It's a very big problem. Now, to solve that problem, suppose you have to take two stack editing, say one queue editing, one tree editing, and say one graph editing. Because here we are analyzing the problem P theoretically. After that, whenever we implement P, whenever we implement the problem P, on that time, we will think how we can implement stack, how we can implement tree, how we can implement queue. So the ADT is basically implement independent. That means the keyword abstract, because how those operations, push, pop, display, pip and all are working and implemented, that is totally hidden from the user. Here we'll discuss only, we'll create a mathematical model or theoretical analysis of a problem. Now, again, I will give you one thing. So, what is the difference between data type and abstract data type? This is also a very common question. What is the difference between data type and abstract data type? So, I think all of you know int I. What is this? I is a variable of what type? Integer type. Whenever I declare as int, two things that you have to consider. Number one, the range of I. So what will be the range of I? I think it will be 32,768 to plus 32,767. So this is the range of that variable. You cannot store any variable, any value which is not belongs to this range, which is not belongs to this range. This is number one that we have to consider. And number two, what are the operations that perform on integer data type? Addition, subtraction, multiplication, division, modulo. So these are the operations that we can perform on that data type. Now, these you don't have to implement these all, because these are all implemented. These are all implemented. If you write A is equals to B plus C, it means what? The value of B and C will be added and store it in a variable A. So the operation A is already, the operation plus is already implemented. The operation subtraction, division, multiplication, these are all already implemented. That's why we can say this is concrete data type. So the data type, normal data type, the another name of normal data type is concrete data type. No need to implement the operations. Again, I am saying no need to implement the operations. But that's why no way to hide the operations, no way to hide the operations, because already things are implemented. But in case of abstract data type, you have to implement push, you have to implement pop, you have to implement display or peep or something. And for that, you have to use either array or linked list, because these are two ways by which you can implement stack. Similarly, for queue also, you can implement queue either in array or in linked list. So ADT means what? Where you have to hide the implementation details. User only knows the operations. User only knows the operations. It means if you have stack, it has 2 or 3 basic operations. What is that? One is push, one is pop, one is peep, one is display. For push, it puts an element into the stack. Now, how it puts an element into the stack, that is hidden from the user. That is abstract from the user. That's why this is abstract data type. That's why this is abstract data type. Next. Okay, so here, this is the figure. Just follow this figure. Just follow this figure. Here, this is the public function and this is private function. I will discuss what public function is, what private function is. Now, the stack is or queue can be implemented either by array or by linked list. But user only interacts to array with the public functions. That means for stack, the public functions are push, pop, display, peep, and all. So what are the private functions? Private functions are the functions that is basically associated with public function. Now, whenever we want to push a element into the stack, first of all, we have to understand, we have to see, is the stack is already full? If the stack is already full, you cannot insert any element into the stack. It means there will be a function that checks whether the stack is full or not. That is full. So is full is a private function which is associated with the public function push. Similarly, whenever we want to remove one element, that is pop one element, first we have to check whether the stack is empty or not. So if the stack is empty, you cannot pop any element from the stack. That means is empty is a private property of the public function pop. Similarly, from peep also, peep displays what? Peep displays the topmost element only. So if the stack is empty, then it cannot peep any element. That means we can say is empty is also a public function of the private function of a public function peep. So the next is say stack. Already I have said stack is full is a function. This is used to check whether a stack is full or not. So if the stack is already full, you cannot push any element into the stack. Similarly, you have is empty. And this push X, that means you will push the element X into the stack. Push, pop, peep, and size. Here the another name of size is display. You can write display also, no issue. Display function. So these are the public functions. So these functions are basically operate on the data of stack type. If I write int I, it means I is a variable of integer data type. If I write say stack s, it means s is a variable of stack type. S is a variable of stack type. So we will access all the elements from the stack using the function push, pop, peep, and size or display. Though for editing purpose, we are not aware how the functions will implement. So whenever the implementation comes, then it will be no longer editing, it will be a data structure. It will be a data structure. So whenever we implement stack, it will be a data structure. Whenever we will represent stack as a mathematical model or theoretical model, we can say the stack as ADT. ADT is implementation independent. Functions are there. Users knows the functions, but users don't know how the functions are implemented. That is all about ADT. Things are
Sir,
there. Hmm?
sir, when we implement some function, we do not know what is happening behind the scene. Then, what is the difference between ADT and its implementation? I mean, sir, both sounds almost similar.
Siddha question, please repeat it.
Sir, when we implement some function,
When
then
you implement some function, okay?
sir, then we do not know what is
Just a
going
minute, just
on
a minute.
behind the scene.
If okay, I get it. If this is mathematical model, if this is a mathematical model, then we can say it's ADT. But whenever we implement, suppose already you have implemented some function, you have implemented linear search, you have implemented already. I think binary search also. But there, that is not that. That is not ADT. That is not ADT. Here, what I am saying, I am saying is when we implement push. Suppose the thing is that push, pop, display. These are the property of stack. These are the property of stack. But for a particular function of any program is not the property of that program. Here stack queue, it's a data type. It's a data type. Suppose you are writing linear search and for that you have used one function. So that is not a data type. But here stack, queue, these are data type. These are data type. Int, char, float, these are also primitive data type or concrete data type. But here stack, queue, these are all abstract data type. I think this is clear now. Okay, you have to read this also. Next, I will discuss the data structures, all data structures one by one, and I will start the journey from array. So everyone knows what is array. So what is array? It's an array is defined by a set of finite number of homogeneous elements. Homogeneous means what? Same elements, same data items. Okay, so everyone I think know how to define or declare one array. Say here I have given one example, int marks 8. What it means? Maximum you can store 8 integers there in the array named marks. Now some examples. Some examples. First, read and display numbers using array. Read and display numbers using array. This is the simplest problem that belongs to array. You have to read in numbers. After reading, you have to display all the numbers. So for reading in numbers, you have to use one for loop, and for display all the elements that you have read already, read and stored in array, that also takes in time. That also takes one loop. It means you can say here n number of comparison. Here also this is n number of comparison. So here the time complexity is n. Next, another one. Print the. This is very simple thing. Print the position of the smallest number from n number using array. So what will be the logic? You have an array and your objective is to print the position of the smallest number. Position of the smallest number. So what we will do? Again, first you have to populate the array. First you have to populate the array. Populate the array means what? Insert the elements into the array. Here I have taken the size is 20. It means maximum you can store 20 elements or 20 integers. Now here enter the elements. So you can enter 10 elements also. You can enter 5 elements also. You can enter 19 elements also. But you cannot enter 25 elements because it's a static memory allocation. Here already I have allocated 20 cells for maximum 20 integers. So that's why 25 integers you cannot insert. It's a static memory allocation. So suppose your n is 5. That means this loop will iterate 5 times. That means say this is your array. Suppose the elements are 5, say 9, say 1, say 3, and say 10. So what will be the logic? Already I have written the logic. Let's assume that this is your small. Let's assume that this is your small. So the position, this is 0th position, first position, second position, third position, and here this is 4th position. So initially POS for position is a variable. POS, the initial value of POS is equals to 0. Next, what we will do? We will write a loop that will iterate from here to last, here to last, and it will compare this with this first. So here this is 5 and this is 9. So come here, ARRI. Initial value of I is 1. So ARR 1, it means what? 9. So 9 is less than 5. Is it? No. No. Then it will check for I is equals to, when I is equals to 2, it will be what? ARRI will be 1. So 1 less than 5. This is true. If this is true, then your small will be 1 and the position will be 2. After that, again it will check with 3. Now 3 is greater than 1, so position remains same. After that, it will compare this AI with compare with 10, and again 10 is greater than this, so it will return the position, that is 2. Similarly, the same problem here I have written in function. I have written in function. Already I have said in data structure, the program will be very lengthy. So that's why for each and every problem, whenever you will implement, you should try to write the function. Here also, this is I have written one user defined function. So this is function prototype. Already you know each function has 3 basic parameters. So this is the 3 components. This is the type, the function returns int. This is the name of the function, smallest underscore array. I have written, you can give any name. Here this is the parameter list. Here it sends the array and what? And the size of the array. So result is equals to smallest underscore array within bracket ARR. ARR means what? Suppose this is your array that contains some elements, and say the name of the array is ARR. So this is what? ARR 0, ARR 1, ARR 2, 3, 4, 5, 6 and 7. This is the index. So ARR basically gives the base address of the array. So what is base address? Let's assume that this 1000, obviously it's integer array, it should be 1002, 1004, 6 and so on. So the base address will be the address of the 0th element. So the address of the 0th element here, this is 1000. So ARR means 1000. So ARR always gives the base address. That means only array name. Here I have given the name ARR. You can write the any name, say XXX, say XXX20. Suppose this is the name. That means if you write XXX, it gives the base address of the array. Now here this is the function. Now again I write the same logic. Again, this is your small. Initially small is equals to ARR 0, generation is equals to 0. Now it will compare with the element. So if the first element is smaller than this, then it will, so small is equals to ARR 1 and then position is equals to 1. After that, it will check this small will again compared to all elements one by one. So here also, this is here for reading all the elements or for inserting all elements into the array, it takes n times, and here also one single loop is there. So n plus n, it means order of n time. So the time complexity is also order of n time. Here this is not the abstract data type. This function is not the abstract data type, because this program is not a data type. If we are consider stack, if we are consider key, if we consider tree, these are all data structure. It means some kind of data type, some of non-primitive data type. So push is a function that operates only on stack. Pop is a function that operates only stack. And whenever we represent stack as ADT, we are just ignoring the implementation
sir, you were doing some rough work for detailed visualization. I
Hmm.
think so. Uh, sir,
26, slide number 26, no?
yes, sir. Slide number 20, 26, sir. Sir, in this problem, you are doing
Hmm.
some rough work for uh,
But
pardon, sir.
already I have deleted that word, rough word.
No, sir. We can't see that actually.
Huh?
Yes, sir. That is not visible.
That is not visible, sir.
Oh, so here the now is it visible?
No, sir.
No. Why don't?
Only the slide is visible.
Only the slide is visible.
Sir, rough work is not visible.
Yes, sir.
Why you not said before? Just a minute. What is the problem?
I think you have to do it on presentation mode.
Huh? In every time. Last day also I have did some rough work. Rough work. It was
Sir,
visible
that
at
work
time.
also not
Yeah,
visible.
it is not
No, sir.
editing mode, sir. This is not presenting mode, sir. Your PPT is on editing mode.
Oh, then
It is not presenting, sir.
okay. Then what to do?